So I thought I'll just make a quick video to explain this question. Originally, I was just going to solve it, but I feel having an explanation also be very beneficial. So what is happening here is you actually want to weigh out the 0.015 grams of tartar emetic. And so the first thing you want to do is determine the MWQ to find out whether you can weigh that out on the balance. Now, MWQ is equal to sensitivity requirement over the percent error times 100%. And this is your max percent error. So from the question, the max percent error is 5, your sensitivity requirement is 4. So you end up with 4 milligrams over 5% times 100%. And that's going to end up giving you 80 milligrams. Now, if you converted the 0.015 grams to milligrams, you're going to end up with 15. Actually, let's also do that as well. So you have 0.015 grams, and we know that 1 gram is 1,000 milligrams. So you end up with 15 milligrams. So now here's where you get to use the proportion, but this time it's going to have a slight twist to it. You're going to have the weight of drag in aliquot, and this is going to be divided by the volume of the aliquot, because here you have a solution. So instead of weight of aliquot, you can use the volume of aliquot. And on the left hand side, you're going to have the weight of drag in the trituration divided by the volume of the trituration. So we know the weight of drag in aliquot is going to be the 15 milligrams, so that goes right here. And we also know that the weight of drag in trituration should be equal to or greater than 80. So now you choose that number. You could choose 80. Now in the book they choose 90, so I'm just going to put 90 right here. But you could use 80, 100, and preferably should be a good multiple of 15. So if you take 15 and you multiply that by 6, that gives you 90. So you could also use 105 because 15 times 7 is 105. That's an exact multiple as well. But the book uses 90, so I'm just going to put 90 right here. Now, the next thing you need to determine is what the volume of your aliquot is going to be. And normally you want to use volumes like 1, 2, 3, maybe sometimes 4, but 1 or 2 is fine. Now in the book, they also use 2 ml. So I'm going to put a 2 ml right here, which means you need to find this term. So if you solve for x is going to be equal to 90 milligrams times 2 ml divided by 15 milligrams. The milligrams cancel out and you end up with 12 milliliters. So now what does all of this mean? What it means is to end up with the 15 milligrams of tartar emetic, you're going to weigh out 90 milligrams of tartar emetic, make a stock solution using the solvent to get 12 milliliters of stock solution. Now from this stock solution, you're going to take out 2 milliliters, which is the volume of your aliquot. And in this 2 milliliters, it contains 15 milligrams of the tartar emetic.